in the orange section.
Yeah.
Or
And on this spreadsheet, we filled in the different fee, required motion, and points that the task would give us upon completion. Then we multiply the numbers across the board, and whichever one had the highest numbers were the ones we voted first.
To make sure everybody had a chance to learn coding and get their hands on the robot, we would rotate in groups during every practice. This allowed us newer team members to learn from the senior team members and coaches.
This year we used the Spike Prime robot. We updated to the new controller, so this was our first year using Spike instead of EV3. We used the Spike Prime software to code, and this was brand new to a lot of the teams. So I started by making a bunch of my blocks to help in coding the missions.
My blocks allow you to build code that you would be used repeatedly in a programming code. You would use this to help us turn left or right. We had one block that allowed us to drive straight, which was called a gyro drive. And we would copy and paste the actual code into our line so we could adjust variables such as distance and speed.
In our code, we did a few things a lot, such as using the gyro to make precise turns. So we'd say to move the wheels in opposite directions until we hit this degrees. We'd also use the light sensor using reflected light intensity to find the black line and then to follow it. We also then used our motors to count the degrees. We found that degrees were more accurate in most scenarios so that we could go forward or backwards the same distance every time.
We would put our missions in groups of 2 to 3 and use trial and error until they worked perfectly. We also went through many variations with our attachments. For example, on one attachment, the front wall was higher at one point, and we figured out it was too high for the windmill. So we had to lower it, and then we figured out the attachment. Then we added on to the attachment, so we'd have less attachments, but we could still do the same number of tasks.
When we had finished all the missions, we went back through and made them faster and more reliable, so we could get as many missions as possible in the 2.5 minutes with the most accuracy.
The robot that we made this year was not our design. We got it off primelessons.org, but we chose it because of its low center of gravity, and it has 2 light sensors, and so we can scrap on a line, 2 attachment loaders, so you can have 2 moving attachments on a robot. Its graph design has lots of spaces for static attachments, and most importantly, we all agreed on it.
There are 2 types of attachments that we use during the robot run: static and active. A static attachment is one that's not attached to a motor. It may move due to another mechanical function, but it is not directly controlled by the robot. Active attachments are controlled by the robot. They are connected to the 2 attached motors that can move according to our code. Our attachments went through lots of variations, with one person starting the idea and the team improving upon it as a group. Then, when we had an attachment working, we would add other pieces so we could do more missions.
We were able to program almost all of the missions. There were 2 missions that we did not put much effort into because of where they were ranked in our priority spreadsheet, as well as we knew they would not be able to be completed in the allotted time. We did choose to give a high five to the opposing team, as we felt it showed good collaboration and sportsmanship as part of the LEGO League as a whole. Thank you for your willingness to be here and judge us on our presentation.